Assalamu alaikum. This is Muhammad Mahid Khan Amir, lecturer in mathematics, EMDS, Rajaguttura Model College. Today our class is on general mathematics for class 9 and 10. I hope you all are well. Today we will discuss about exponents. This is exercise 4.1. So to learn this chapter, we need to know some definitions first. First of all, we need to know what is exponents. There are some names of exponents. They are usually called as index or power. Let's see, if a is any real number, then successive multiplication of n is a to the power n, that is a into a into a into dot 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 into a n types of a exactly is equals to a to the power n, where n is a positive integer. Here n is the index or power and a is the base. Conversely, a to the power n equals to a into a into a into dot 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 into a, that is exactly n times of a. Next thing we will learn is exponential expression. We know what is algebraic expressions is. So here, if an expression is associated with exponents and base are called exponential expressions. That is any expression with exponentials. I am repeating myself again. Any expressions with exponentials, that is exponent and base, is known as exponential expressions. Let's move forward. In this chapter, we need to apply some laws. They are, as in this chapter, we will deal with exponents, that is index. So these laws are named by index laws. So first law is multiplication law, that is a to the power m into a to the power n is equals to a to the power m plus n. When I was a student like you, I used to remember the formula like this: if the base is same and there is a multiplication in between them, then the powers or index of the terms will be added, that is a to the power m into a to the power n is equals to a to the power m plus n. The important thing is we need to have the same base here. If the base is different, then we cannot apply this formula. The second formula or second law is division law. Here a to the power m divided by a to the power n. Here we have two cases: if m is greater than n or n is less than, actually m is less than n. So if m is greater than n, we have to write a to the power m minus n, and if n is greater than m, we have to write a to the power n minus m. If we need to know the conditions, as we have to answer the MCQs, and in MCQs conditions are very important. The persons or the teacher likes to ask about the conditions of the formulas. They are very important actually, and as they are very tricky, so teachers like to give them in the exams. So we need to know the conditions with the formulas, and when we gonna apply the formulas into the math, I mean in CQ, we don't need to know the formulas, just we will apply a to the power m divided by a to the power n equals to a to the power m minus n. We will subtract the power of denominator from the power of numerator when we are applying the formula in a CQ. But when we have to answer the MCQ, we need to know the exact conditions. If m is greater than or equal to n, then a to the power m minus n, and if n is greater than m, that is if denominator is greater than numerator, the powers, then a to the power n minus m. So this was our second law, which is known as division law. Third one is the power of product law. We can see that power of product, that means we have something like power and product in this law. Look at the law: ab to the power n, actually ab whole to the power n is equals to a to the power n into b to the power n. We can simply say that we will split our power into the products. And the next law is power of quotient law. Similar kind of law like number 3. In 3 there was a multiplication, and in 4 there is a division or quotient. So here a divides b to the power n is equals to a to the power n divided by b to the power n. Similar like before, splitting the powers. Here we have a condition, that is b is not equals to 0. We know in a division or in a fraction we cannot have 0 in our denominator, cause if the denominator is 0 the fraction will become undefined. So that's why here b cannot be 0. The last but the last but not the least formula of this chapter is power of powers law. Here are two powers, that is a to the power m to the power n is equals to a to the power mn. If the powers, here we have to just multiply the powers, that is a to the power m to the power n is equals to a to the power mn. These are the 5 important formulas, or the 5 formulas we have to apply in this chapter. You have to memorize them, you have to make sure you know everything about them. So I am repeating once again the formulas. Multiplication law, that is a to the power m into a to the power n is equals to a to the power m plus n. Then number 2, division law, a to the power m divided by a to the power n is equals to a to the power m minus n when m is greater than or equals to n, and a to the power n minus m when n is greater than m. Now the third law, power of product law, ab whole to the power n is equals to a to the power n into b to the power n. Number 4, power of quotient law, a divides b whole power n equals to a to the power n divided by b to the power n, where the condition is b cannot be 0. And the last formula, power of power law, a to the power m whole power n is equals to a to the power mn. Now we need to know two things, zero and negative indices. Zero indices and negative indices. As here indices, that means exponent or power. In power we can have a positive number, a negative number, even a zero or a fraction or anything, that is real number. Any real number can be our indices. So normally we see the positive values or fractions, normally positive values. So rather than positive values we have two indices, that is zero and negative indices. So here we will define the zero and negative indices. So for zero and negative indices, normally 0 a to the power 0, and for negative indices we have written a to the power minus n. Here n is a natural number, are as follows. Zero indices, here a to the power 0 is equals to 1. This is the formula actually. And here we have a condition, a is not equals to 0. So the definition of zero indices, zero index is a to the power 0 equals to 1 and when a is not equals to 0. And then the negative index, that is a to the power minus n is equals to 1 by a to the power n. And here also a is not equals to 0 and n is a set of natural number, or n belongs to natural numbers. Now we have already learned about zero in this index, negative index, and we have applied the in formulas. We have see the positive indices, index or indices, whatever you say it. Index is the singular form and indices is the plural form. So the next thing we have left is a fraction. So nth root of a, here a is a base. For base or variable we have written a. We observe here, we will describe this with the formulas, or exactly with examples, sorry. So we observe 5 to the power half whole square is equals to, and we know square means a square means a into a, so 5 to the power half square is equals to 5 to the power half into 5 to the power half. We have learned from the law of multiplication of index, a to the power m into a to the power n is equals to a to the power m plus n. So applying that formula we will have 5 to the power half into 5 to the power half is equals to 5 to the power half plus half, and we have known that 5 plus half plus half is 1, and something to the power 1 is that number, so that's why we have written 5. So from here we can say that square of 5 to the power half is 5, as we have got it, and the square root of 5 is 5 to the power half, or root over 5. That's what we do it, write it actually. The next thing we can see similarly, 5 to the power 1 by 3 whole cube is equals to 5 to the power 1 by 3 into 5 to the power 1 by 3 into 5 to the power 1 by 3, that is 3 times of 5 to the power 1 by 3. Now here, applying the similar index law of multiplication, we will get 5 to the power 1 plus 3 plus 1 plus 5 to the power 1 by 3 plus 1 by 3 plus 1 by 3, that is 5 to the power, if we do the LCM, we will have 3 by 3, that is 1. So 5 to the power 1 is equals to 1. So here we can see the cube of 5 to the power 1 by 3 is 5, and the cubic root of 5 is 5 to the power 1 by 3, that is cubic root of 5. This is exactly the symbol of cubic root, and this is, we know very well, the symbol of square root. Now we want to find the nth root. So in the case of nth root, we have let the nth root of a is a to the power 1 by n, that is a to the power 1 by n whole to the power n is equals to n times of a to the power 1 by n, that is a to the power 1 by n into a to the power 1 by n into a to the power 1 by n dot 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 a to the power 1 by n, successive multiplication of n a to the power 1 by n. So we can apply the multiplicative law of index, or index law of multiplication, whatever you say it. We will have a to the power 1 plus n plus 1 by n plus 1 by n plus dot 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 plus 1 by n. Here in the exponent, sum of n 1 by n. This is equals to a to the power n into 1 by n, as we have written n 1 by n, summation of n 1 by n. So a to the power n into 1 by n, that's equals to a. So here we have find that the nth power of a to the power 1 by n is a, and the nth root of a is a to the power 1 by n, or the nth root of a. So this was the nth root of a, or the finding, or nth root, or the fraction root, or fraction index. So we have now learned every kind of indices, that is positive, negative, zero, fraction, integers, everything. So now we can move on to our maths. We are going to exercise 4.1. We will start from number 2, and this is a math of simplification. Number 2 is simplify cubic root of 7 square into cubic root of 7 divided by root over 7, or square root of 7. So here solution. In solution part, we have just written it, cubic root of 7 square into cubic root of 7 divided by 7 square. We have first written the given term. Now applying the formula of nth root, just what we have seen, a to the power 1 by n is equals to cubic nth root of a. That is, now actually here we have applied cubic root of a, that is equals to a to the power 1 by 3. So cubic root of 7 square is 7 square to the power 1 by 3. Cubic root of 7 is equals to 7 to the power 1 by 3. And in the denominator, that was square root of 7, that's equals to 7 to the power half, from the nth root of a, or from the formula of nth root of a, or the definition of the nth root. Can you guess which formula we need to apply? Look at the first term, or first part of our numerator. We will have 7 square to the power 1 by 3. Here we can apply the formula of the power of power formula, or power of power law. The law was a to the power m to the power n is equals to a to the power mn. That means we have to multiply our powers. So from that, multiplying 2 into 1 by 3, we will get 2 by 3. So 7 to the power 2 by 3 into 7 to the power 1 by 3 is divided by 7 to the power half. And the formula is a to the power m to the power n is equals to a to the power m into n. In the examination, you must try to give the side notes. This is actually beautiful. That's the thing come to my mind. The examiner will be pleased if you give the side notes. Now guess which formula we need to apply. The maths in this chapter are all about formulas, applying formulas, nothing more than the formulas. Actually the 5 formulas in the loss section and 3 formulas we have got from the definition of zero index, negative index, and nth root or fraction index. So total 8 formulas. So now we have to apply the law of multiplication, that was a to the power m into a to the power n, or just I used to remember it like if the base is same and there is a multiplication in between them, we have to sum the powers. So here we have the same base at numerator. I am talking about the numerator. In numerator we have 7 to the power 2 by 3 and 7 to the power 1 by 3. So we have two terms, actually they are not terms, two expressions or two parts. Parts is more efficient. So two parts both have the same base 7. So we can apply our law of multiplication. So applying that, we will have 7 to the power 2 by 3 plus 1 by 3. As the base is same, the powers should be added. So 7 to the power 2 by 3 plus 1 by 3. Here the formula is a to the power m into a to the power n is equals to a to the power m plus n. So now adding 2 plus 3 plus 1 by 3 is equals to 3 by 3, that is 1. I thought you are mature enough to do it on your mind, so that's why I didn't show it, but I have already told it, so no problem. I guess you will have, so 7 to the power 1, that is 7 divided by 7 to the power half. Now we can see in numerator and denominator we have the same base 7, so we have to subtract the power of denominator from the power of numerator. So from there 7 to the power 1 minus half, and the exact formula is a to the power m divided by a to the power n is equals to a to the power m minus n. At the first part of our today's class, I have said you when we will apply this division formula in our CQ, we don't need to write we don't need to memorize or mention the conditions, cause normally we have to write the power of numerator minus the power of denominator. So don't bother mentioning the conditions. So here 7 to the power 1 minus half, that is 7 to the power half, and we know for half 1 by 2 represent the square root, that is root over 7. So the solution of this math is root over 7. I have given the side notes for you to understand easily. So the solution of this math is root over 7. Our next math is number 4. In the SSC exam of 2020, this math was in the CQ for 2 marks, and I was a guard or invigilator of SSC exam. So I saw that many students, almost 40 to 45% of students have done this math wrong. There is a tricky part in this math, that is here. Okay, we are moving forward to our solution part, that is 2 to the power a minus 1 plus 3 to the power b minus 1 whole to the power minus 1, or you can say it like 2a inverse plus 3 into b inverse whole inverse, whatever you say, no problem. As we know, the power minus 1 is known as inverse. So here the tricky part is here. Okay, here the power minus 1 is on a, the power is not on 2. We need to remember that. We will apply the formula on the base. What is the base? We need to know what is our base and what is our power. Here our power is -1 and the base of this power is a. So our formulas will be, or we have to apply the formula on a, not on 2. So that's why I have written here 2 into 1 by a plus 3 into 1 by b. Similarly here the power -1 is on b, not on 3. That's why 3 is left alone, 3 into 1 by b. And here the formula we have applied is a to the power minus n is equals to 1 by a to the power n. This formula we have got from the definition of negative indices. So here now multiplying 2 into 1 by a, we got 2 by a, and multiplying 3 with 1 by b, we will have 3 by b. So that is our next line will be 2 by a plus 3 by b, and the power -1 will be kept unchanged. So we will have 2 by a plus 3 by b whole to the power -1. Now we have to do LCM, a and b, that is ab. Then AB divides A into 2, that is 2B, and AB divides B into 3, that is 3A. So doing this addition, I know you know very well how to do addition. So 2B plus 3A divided by AB. Now we have a whole power of -1. So from here we have seen the power -1 means the reciprocal of the fraction, or 1 by the fraction, or 1 by that number. So from there we can write 1 by the fraction. And the formula I have written in the right side of the equation, that is a to the power minus n is equals to 1 by a to the power n. We know this line can be written as ab by 3a plus 2b. So this is our answer. And the students, the part they mistaken was they have written 1 by 2a and 1 by 3b. That's why their answer was like 6ab divided by a plus b, but that was not correct. So you have to, for this chapter, the first condition is learn the formulas, and second condition is apply the formulas efficiently. And to apply the formulas efficiently, we have to know, or we have to notice what is our power and what is our base. If we can find out the power and the base, then we can easily apply the formulas. So that's all for today's class. Hope you have understand. If you have any question, you can ask me in our class, in our Zoom class, or you can communicate with me. Thank you all. Stay safe.